To write the balanced net ionic equation for zinc sulfate plus ammonium phosphate, we first need to balance the molecular equation. This is the molecular equation. There's a link in the description of this video if you need help balancing the molecular equation. After we have the molecular equation balanced, we write the state for each substance based on the solubility rules. So if you know your solubility rules, most sulfates, with a few exceptions, are soluble. So these compounds are going to be soluble, and compounds with the ammonium ion are very soluble. So we have these two. They're going to be soluble as well. So everything is soluble except our zinc phosphate. This phosphate ion, most of the time the phosphate ion will be insoluble. That means we'll have a solid. These substances react, we get our solid. It's a precipitate, falls to the bottom of the test tube. So the zinc phosphate, that's a solid. It's a precipitate. Once we have the states, we can split the strong electrolytes into ions for the complete ionic equation. That'll look like this. So this is the balanced complete ionic equation. Now we can cross out spectator ions. They're on both sides of the complete ionic equation. We have the reactants here on the top, products on the bottom. So I can see I have 3 sulfate ions in the reactants and in the products. We can cross those out. They're spectator ions. And then we have these 6 ammonium ions in the reactants and again in the products. Spectator ions, we cross those out. What's left though is the net ionic equation for zinc sulfate plus ammonium phosphate. Let's remove the spectator ions. So this is the balanced net ionic equation for ZnSO4 plus NH4 3PO4. You'll note that the atoms, they're balanced, and the charge is balanced. 3 times 2 plus, that's 6 plus. 2 times 3 minus, 6 minus. That all adds up to 0, net charge of 0. Over here, neutral compound, net charge of 0. This is Dr. B, and thanks for watching.